Hi there, data scamps and data champs. This is Richie. So, yeah, welcome back to the AI assisted Python code along series. Now, don't worry if you missed yesterday's session. This is going to be completely standalone, so you don't need to have seen it to follow along today. So this time we're going to be doing a little bit more exploratory data analysis, since that's an incredibly important skill, but we're also introducing some machine learning, and it's a very fun use case around building a movie recommendation engine. Now, so some good news since yesterday. I know a few of you who are on the free Data Lab plan running into AI prompt limits. So normally you get a 15 prompt limit before you have to buy Data Lab. So I had a good chat with the Data Lab engineers yesterday, and they have got rid of the limit for today's session and for tomorrow's session. So you're not going to have any limits on how many AI prompts you can use. So yeah, thank you to Bernd, who's the engineer who was working very late last night implementing that feature. Now, our guest is Pieter Moors. He's a data scientist here at DataCamp. Now, Peter focuses on our skill assessment product. So he works on the psychometric side of things, making sure that skill assessments are, in fact, high quality. So he's assessing the skill assessments. It's all very meta. And he's got a background in experimental psychology and visual perception. So with that, I'll let you take it away, Peter.
Hi, hello everyone. Peter here. Very happy to host this code along and trying to build a movie recommendation tool together with you. Just a bit more about me. Richie almost said it all. I work mainly on skill assessment at DataCamp and also on certification at DataCamp. Both very cool products. If you don't know them yet, feel free to check those out. It's a very nice addition to improving your skills. So what we'll be doing today is basically starting from scratch, having nothing built yet to at the end of the code along, hopefully having a certain tool that will allow you to put something in and get a recommended movie or two back. And so in order to be able to do that, we'll need some data, as you would expect. And the data today is about movies, of course. And the type of data that we'll be working with, we'll see in a minute when we dive into the notebook, is ratings by people. So basically, we have data on a movie that someone watched and they gave it a certain amount of stars. And then we have some what we call metadata about those movies. In this case, I kept it very simple. We have the title of the movie, the description of the movie, how popular it is, those kind of things. I sourced them from certain projects where you can find links. I won't be diving deeper into that. These data sets are pretty classic in the context of building a recommendation engine. And so the primary goal of the session really is, even for someone who's not familiar with coding at all, is just making you familiar with how easy it is to set up a basic recommender system. And then the secondary goal is that I thought it would be cool to really dive into the AI hype as well and to learn how large language models are also relevant for recommender applications. So this is something more at the end of the code along. I hope we'll get there easily and without any bumps on the road. Cool. I hope you all have access to the notebook that I prepared. I'll be switching into that one for now, and then we can start diving into the coding bits of the code along. So here we are. I hope everyone can at least see me having the notebook open and that you have it as well. For those of you who are not really familiar with what we're using, this is a product called Data Lab, and it's basically a very nicely integrated system where you can have a file that intermingles text with code, and it's all AI supported. So we can simply ask AI to do something, and then it will generate some text for us or some code for us. And that's what we'll be doing today. So as I said already before, we'll be building a movie recommendation tool, and we'll be using 2 different data sets. Richie alerted me yesterday that almost no one knows that you can access files in Data Lab from the file explorer. So I'll show this to you today so that you can actually see that you know where your files live. If you look at the top right here, you see this nice arrow icon, and this will open up. Reese, I'm seeing that there's maybe a wrong link for the code along. Is that true or not? Okay, it's fixed. Thank you. So if you open the top right context panel, you can see that there's this files tab, and there you can see that we have different assets in there. We have 2 data files. One is called movies metadata, one is called ratings, and then we are currently working in this notebook. And as an addition, we also have the notebook underscore solution. That's the fully annotated output that we will have at the end of this session. Because we'll be using AI to generate code for us, so we're doing AI assisted coding, the solution that's in there won't necessarily be the actual code that we're generating today. So please be mindful when you're comparing your own notebook to the solution one. They might be totally different. Hopefully, they won't be too different, but there is a real chance that they're not exactly the same. What's also nice, something I discovered today, is that you can actually explore this data a bit when you click on it. So when you click, for instance, on movies metadata, it will load a preview screen. And if you wait a bit, you can see that we have a ton of movie data in there, but this is not nicely formatted. So we'll jump right into the coding now to explore this data a bit more. Okay, so basically, to achieve our end goal of getting to a movie recommender, what we'll be doing is we'll first look into our data sets a bit, see what's actually in there, and then we will build a first recommender that generates the same output for all of you. So if you ask it something, it will always tell you to watch the same movies. And then in a second step, we will personalize those recommendations a bit by letting you put in a certain movie that you like or that you've seen before and you want something similar. And then it will spit out a few movies based on the similarity to the movie you liked. And then lastly, at the end, we'll be leveraging large language models, and we'll try to come up with a recommender system that basically allows you to write the type of movie you want to see. Like, I want to watch a romantic comedy between about a couple doing X or Y, or I want to watch a superhero movie, something like that. And if all works well, this recommender will then spit out movies that are similar to that prompt. Okay, I'm blabbing a lot and we haven't coded yet, so let's try to do something about that. Our first task is looking at the data a bit. I've noted down what is in this data set, but let's just go into the coding and then explore it ourselves. So the way in which I've structured this code along is as follows. I've always already pre-written the full prompt. Then we'll be putting that prompt into a code cell, and that code cell will then generate the code for you. We'll just accept the code that it generates, and we'll go through it line by line, breaking it up a bit to then show you what it's actually doing. And the reason we're starting with some basic exploration of the data is that you should always just try to get to know your data a bit before you throw it into some kind of fancy system. So the prompt I came up with for this was, first, read the movies metadata file, count how many unique movies we have, visualize two columns that we have, the vote average column and the vote count column. And then next, read the ratings file and count how many unique users have rated how many unique movies. Visualize the distribution of the rating column. So this might be a mouthful already. You can see that I am being very specific in what needs to happen for this to work. I give the prompt a lot of specific instructions on read this file, and we know that a certain column exists in that file, and then visualize this column. And that's typically how I use AI-assisted coding, is by very specifically instructing the AI to do something. So how do we go about generating some code now? If we hover under this prompt cell, you can see this plus sign. You can simply click, and when you click, you'll see a pop-up that allows you to add certain cells. If you then add this Python cell, this will show as a code cell, and you can just start writing Python code if you know what to do already. But if you want to instruct AI to generate some code for you, you can click on tell our AI what to do, and then it will pop up with this prompt interface. Now, if you then edit the text cell, you can just simply copy this prompt and paste it in here, and then you hit enter, and then it will start generating code for you. You can see that I wrote a lengthy prompt. This generates a lot of code. And what we'll do now is we'll simply accept the code and then go through it line by line. And by doing that, I will try to break it up for you to see the different steps that we're doing in order to get at a certain output. I'm seeing here a question about the fact that that we're hitting the AI limits. I don't know if we can do something about that. So first, the first two lines start with import statements. Those import statements are simply us asking to import certain libraries that we can use to analyze data, which is pandas is like a data processing library, and matplotlib is a library that allows you to visualize different things. So typically we start with that, that we can use those things to read files, to manipulate files and stuff like that. So I'm just going to take that out and put that in a new cell. And then you can hit run, and that should simply work for you. And when that finishes, you'll see this green dot, and that those libraries have been imported. Next, what you can see is that we're going to read the metadata CSV. Of course, we're also going to read the other data set. You can see that that happens here. So we're going to group these things together, that we have one code cell where we are reading the data. So if we're just going to copy this over. And then hit run. Now both CSV files have have been loaded into memory, and we have it available as movies metadata and ratings. So what's nice about Data Lab is that if you add another Python code cell and you simply would type movies metadata and you hit run, then it will just output a preview of this data set for your inspection. So what you can see here is that it outputs a table. You can see that we have a column called movie ID. We have a column called title, overview, and then here we have vote average and vote count. The nice thing about exploration in these tables as well is that you can sort values, you can filter values as well. So this really allows you to get to know the data a bit better. The same for the ratings data. If we simply run that piece of code, you can see here that for ratings, we have a user value, so the person who watched a certain movie, which is the movie value, and then you can see that there is a rating associated with that. So I'm now just going to delete this cell. Cool. So the next part about my prompt was about just getting to know how many movies we have in the data, how many users we have in the data. And you can see that this line of code does that. So basically what's happening is we have our data set, we select the column that contains the movies, and then this function allows you to count all the unique values. So let's just copy this out into a separate Python cell. And then we have the same here on these lines for the ratings data. So we can simply put that together as well, have it nicely. And then at the end, you can see at the end of the prompt, the AI just came up with showing the output. So if we just do it like this and we run it, then you just get a few sets of numbers thrown at you. This is not really nice. So what I can show you that you can do in order to circumvent this is you can use something that's called string formatting. And I will just, let's see here, I will just write it like this. So let's say print and then we say, so this F is used to indicate string formatting. Movies. And then we can do this. And this should then work, if I'm not mistaken. So we'll just compare that. Let's comment this out. Whoops. Yes, forgot the parentheses. So you can see here that the number of unique movies we have is 9,010. And then if we would output the number of unique users, I'm just going to copy paste it from the solution. Remove this. Then we have about 670 people that rated at least one movie. So we already know kind of what the size of our data is. And then we can start to look into how the visualization works here. So we have 3 chunks of code left, and you can see they all start with this PLT thingy, which is simply the matplotlib library that contains different functions that will build up your figure in layers. So we have already processed this, so let's remove this right now that we are left with the visualization ones. This. So what we can see here when we run it is that this will output 1, 2, 3 different figures. Let's just go into the first one, and we'll leave the rest just for now. So what you can see is that we are generating what's called a histogram. So basically, we're taking all the values in the data set. So this is the average number of stars the movie got, for example, and we're counting how many movies there are with a certain average number, and then we're putting that in the form of bars on the image. So that's what this line called PLT hist does. And then here we're simply adding a title, an X label, a Y label, and stuff like that. And so what you can see here is basically one, that that the range of these averages is between 0 and 10. So it's basically a score between 0 and 10, and that most movies get a score somewhere around 7-ish, 7-ish out of 10. If we look at the next one, we can see that when we look into the frequency of how many votes movies get, that a lot of movies get very little votes, and very few movies get a lot of votes. And that's basically very common to popularity data. So there's a few things that everyone will have seen, and then there's a lot of things that only a few people will have seen. And then lastly, this is a visualization of the rating data. What you can already immediately see is that the scale is different compared to the first graph. The first graph ranged from 0 to 10, but the users apparently put in their rating in stars between 0 and 5, starting from half a star to 5 stars. And what I found interesting when I was looking at this graph, is that people like to give a full rating. It's much more common to give a full rating rather than one with a half in there. So some kind of typical human behavior here. Cool. So this is very quickly, very shortly, some basic exploration of our data. We have of about 600 people ratings on about 9,000 movies, and that's what we're going to work with. So in our second task, we're going to try and build our first movie recommender, and it's going to be one of the easiest ones to build, and that's simply one that is based on popularity or average rating. So simply, the simplest recommender that you can build is by recommending stuff that is very popular, or recommending stuff that gets very high ratings. And so the way in which we'll do that is we'll be using the metadata dataset, which had these two columns called vote average, vote count. And we'll be writing a very simple manipulation of that, such that it always returns us the highest, like the movies with the highest number of votes, or the movies with the highest average score. So let's look into the prompt. So I already prompt the AI to look into movies metadata, and then I ask it to generate a simple recommender that generates movies by either the vote average column or the vote count column, and then that it also should be configurable in that if you want to watch more than one movie, that you get a list of movies you can choose from, or something like that. So let's go into a similar way here. Let's add the Python code cell first, and edit. And put it in the prompt. Okay. So again, it spits out a lot of different things. Let's accept it and try to make it a bit cleaner, a bit smaller, such that it's more digestible. So for those of you who are really unfamiliar with Python, this might already be a big step. So I'm going to take 1 or 2 minutes to explain it. So what the AI has generated here is what we call a function. And the function is called simple recommender. And you can see that it's a function because it starts with the def argument and then names it, and it then lists a bunch of things that the function can do. I'm just going to take this out and then try to run through it together with you. So if you think about a function, the way in which I try to think about it always is that it abstracts away a certain piece of logic, or maybe put more simply, it will execute the same set of steps always, but you can give it different inputs depending on the data you have. So in this case, you can see that the inputs the function needs are 3 different things. It needs metadata of a movie, but you can call this anything, like this is simply a name for something. It needs a criterion, in this case, that will be applied to the data. And it has an argument for the number of things it will return. This part is a way in which you can describe what your function is doing. It's very nice if you want to be, if you're writing software and you want to be very clear to the end user what your function can or cannot do. But I'm just going to remove this for now because it clutters the function a bit, and then we can just go into the details. Here, in the first step, the function checks whether the value of the criterion that we want to use to recommend movies is actually one of 2 different things. And the reason it does so is because we asked in the prompt, recommend something based on one or the other column. And if that's not the case, if you put in something else here, it will raise an error. Then we arrive at what is the gist of recommendation. Simply this. These 2 lines will give you the easiest, like the easiest way of recommending things. You take your data and you apply a sorting function to it, and you do it by a certain criterion. And you say, okay, I want to sort it in, now I'm always confused. This is descending order. So basically the highest, so the highest popularity or the highest average score should be ranked top. And then what we do then in the second step is, after sorting it, we can take any columns we want from our data set, and then we apply this head function, and we say, okay, we only get the top n values back. So if we run this, nothing will happen, because defining a function is simply executing code that is ready to be used. You can think about it like that. So you have put in something in place that is then ready to be used. How can we use it? Well, let's show it here. So if we copy just this part, put it in a new cell, then we say, okay, use simple recommender, apply it on the movie's metadata file. The criterion to use is vote average. Maybe let's use vote count for now. And then give me the 10 most popular movies back. So if we hit run now, it will execute these series of steps and then return this subset of data to us. There we go. So what you can see here in our data set is you have 10 different movies that are ranked according to the highest count to the 10th highest count. And this is the simplest thing that you could show to your end users, that you have suggestions for them to watch based on the fact that these things are the most popular. If you then would change it to vote average, then this gives you a very different set of recommendations. And you can already see that this is slightly less optimal because it simply spits out all the movies with the highest scores, but we don't really take into account how many people scored it. So that's a downside of simply using the average rating. And we should always try to come up with a way that when you simply look at average rating, that you also take into account popularity. So to conclude this task, we have a recommender function that takes in some data, sorts it by some variable, and then subsets it so that you have only X amount of movies for you. As I said before, this is the simplest thing because it's not personalized to you at all. What we'll go into now is we'll start to leverage the rating data set. We haven't done that yet. And we'll start to use those ratings to quantify which movies are similar to other movies. And the way in which you need to think about that is if two movies get the same pattern of ratings for different users, then those two movies are likely to be very similar to each other in terms of how people liked it. And that's an indication that you might want to recommend one movie if the user has seen the other movie or vice versa. And so what we'll be doing is we'll try to come up with a way to calculate the similarity and then again generate a function that when you then put in a movie, it returns to you the 10 most similar movies back. And then again, you have, well, differently from before, you then have a personalized version of a recommender because it takes into account what you like. So let's dive here. Let's dive in here. In this case, the prompt is very simple, but the output will be a bit more complex. So what we're going to ask is create a recommender and use rating data, so the ratings data set, and generate movie recommendations when you put in a specific movie title. So the reason we can make it this vague is because there's plenty of recommendation tutorials that ChatGPT has been trained on. And so any AI system will very well know how to put in like a basic recommender based on rating data. So let's paste in the prompt, hit enter. Okay, let's hit accept here. And then again, this is a mouthful of code. So let's see whether we can understand this a bit better. First, we start with the import statements. Let's take them out again. Here, You can see that when using this AI-assisted coding, it will very often import libraries that you actually already have access to because of your previous code. The main reason probably is that it will always try to create self-contained pieces of code. So let's just remove this because we already have it. And then the first line is actually the most important one. So I talked to you about that we wanted to use the ratings to calculate some form of similarity between movies. And that's what this function will do. So this function is called cosine similarity. And I won't go into any of the technical details, but you can think about it like when you have the list of ratings of those 600 or 700-ish people for one movie, and you compare it to the list of ratings for the other movie. If those patterns are very similar, it's inferred that those movies are very similar, and hence that if you have seen one of those movies, it might be the case that you also like the other movies. And that's the gist of any, like if you would want to dive deeper after this, the gist of any recommendation system works like that. Now, secondly, it also imports this TF-IDF factorizer. Very funnily, we don't need it at all. We're not processing text in this case. So I'll just remove it. If we then get an error, it's on me. So you can see that even AI systems regularly hallucinate. So let's run this. Cool. Now we have another function that's being generated, and there's many different steps here that we go through. So let's go through it line by line to really understand this type of recommendation. So I just put it in a separate cell so that we can run the function without actually getting output yet. So again, this function is named in a particular way. I've learned that AI comes up with the most creative ways of naming your functions depending on how you prompt it. That doesn't really matter. You can always change the name. And the type of input it wants is both the metadata file, the ratings file, a particular movie title. That will be your input. So you can maybe already scroll back to the top and look which movies are in there to play around with that function yourself later in the session. And then how many movies it should return from this function. The first step, and this is simply due to the way the data is constructed, this is not necessarily always the first step, is merging the two data sets we have. I don't know if you remember, but in the ratings data, we had a combination. Let's just show it again. We had user, movie, and rating, but we don't have any titles. So we can do all our calculations on this data set, but then we still have to link the ID to the actual movie title. So what happens when we merge is we already combine everything, and then we do all our calculations, and then we can simply ask for the title of the movie instead of the ID of the movie. So you can see that we have ratings, metadata, and we merge on movie ID. Then what happens here is we create what's called a pivot table. And the way in which you can think about that is, maybe I should have let the ratings data stay here. So currently this data is in what we call long format. So we have a user and movie combination with a rating in one row. But if you think about how I explained it earlier, and that we want to compare all the ratings of one movie with all the ratings of the other movie, we need to have a user and all their ratings on one row, and the movies need to be columns. And that's actually what this pivot table will do. Index means which rows you want to keep. Columns means what the title, or what the columns should become. And then the values argument is which values should then go into that row by column format. What happens when you do that is you explode basically the rows and the columns, because there's many users that haven't seen all the movies. So there will be a lot of what we call missing values, and we will automatically fill those with a value called 0. But as the AI already told us, it's an assumption that movies that haven't been rated have a rating of 0. This is a pretty contentious topic in its own. The way in which you fill the missing data with all the same value, or the average rating of the user, or the average rating of the movie, or something else, will potentially impact the end recommendation. We won't go any deeper into this, but this is just for you to know that you can play around with this 0 value and then see what you get at the end. And then lastly, the most critical step, we take that matrix that we generated, that pivot table, and we apply this cosine similarity function to it. What we will then get out of that is a new variable, and it will contain for each movie how similar it is to all the other movies in the table. We can take that out of the function in a second, and then you can see how that works. And then to conclude, we can then put that again into a data frame, and we need to simply sort the values along the similarity axis. And when we've done that, we can then select the first 10 in this case. But the reason why we're here saying don't select just the first 10, but from the second element to the 11th, is because the movie that's most similar to another movie is the movie to itself. So the highest similarity will always be the movie itself. So that's why we're here subsetting with a +1 rather than just the top n. So if we run this function, you can see, again, it does nothing. And let's now simply try it out. So in any way I prompted, it always would come up with The Godfather. So let's try it out here. And then you can see the output. And it actually says that The Godfather Part 2 is most similar to The Godfather, which is interesting, and also kind of a check that your ratings data has been processed carefully, as people tend to like the sequel to the original movie. And you can see that the type of movies that we're recommending is very similar, like Goodfellas or Reservoir Dogs, maybe The Usual Suspects. And that's, well, I was going to say that's it basically. No, that's just by having, how many lines is it? Maybe 20 lines of code. You can simply create a recommender system that you can put a movie into, and it will spit out 10 similar movies, depending on how people rated those movies independently of you, which I find very, very cool. So in the solution, I'm not going to go through all of that right now, because I see we're already pressing for time. Maybe I should ask Richie whether if this is a good place to already stop, or that we can continue to the last two tasks.
We can continue for a few more minutes. We're going to have a bit of time for questions, though. So for anyone in the audience, if you've got any questions for Peter, then please do ask them in the chat now. We'll go through them at the end. But yeah, for now, Peter, you can continue.
Okay, cool. So basically, what I was going to say is in the solution set in the notebook, I've always added a few suggestions to play around with this yourself, or to extend the functions in certain ways such that it becomes a bit more complicated. So if anything has been unclear in me explaining this right now, I've written it all out in the solution as well. So for the last two tasks, they belong together, but I've basically split them apart because I thought that would be a bit more natural to understand it like that. So what we've done so far is we have created one thing that's based on just popularity. The second thing is based on, or the second recommender is based on ratings by people, so how well they like the movie. The third thing I wanted to show you is how we can actually generate recommendations as well by simply describing the type of movie you want to see, and how we can use AI or the large language models that we have now to then calculate similarity to all other movies. And the way in which we need to do that is by generating something that's called embeddings based on the descriptions we have of the movies in our metadata. And you can think about the concept of embeddings is simply that we convert the descriptions of the movies we have into a set of numbers. And that set of numbers has the nice property that if you calculate similarity between those numbers, that things that are semantically similar, so descriptions that have the same kind of text in it or the same kind of content, they will automatically group together. So what you will be describing in your own prompt to get a recommendation back will be based on generating a embedding or a numerical representation of your own description. And then when you have done that, it will calculate similarity between all the descriptions of the movies, and you will get back the ones that are most similar to your own description. So we'll be using an actual LLM for this. You typically have to, rely on non-like open source software or something like that to make it very well functioning. We'll be using one that is just that we can just locally run, but just be aware that the power of these things is less big than the power that you typically see in tools like ChatGPT or other large language models. I have crashed my notebook by running this code cell, so I advise you to not run it like this. I'll just copy in an alternative code cell for to make sure that this is actually something that we will be able to run rather than getting us to crash the notebook. So first, we're again loading packages. Then secondly, we're loading a pre-trained model. Let's just remove this here. A pre-trained model that we can run locally. So if I hit run here, then I'm just gonna hide the output. This is very nice to hide output you don't want to see. Okay, so we've loaded the model now, and then I'm gonna also change this code, sorry, to Yes. To how we're actually going to generate these embeddings. So what we're doing is we're taking the overview column, which is the movie description, and we're going to apply this function to it. And this function, this encode function, will take the description of the movie and will give you back a numerical representation of it. If I hit run now, it will run for approximately 4 minutes or so. So my proposal is that if there's any questions I can take, I'll take them now, and then we can end with the final recommender function and close this off. Should I go through the questions myself, Richie, or is there some you selected beforehand?
Sorry.
No worries.
No, we're all good here. And yeah, so thank you for that. And thank you to everyone in the audience for being patient while we sort out the AI limit issue. All right, so we've got a few great questions from the audience. So this first one comes from Debbie. So Debbie is asking, why are you putting each prompt in a separate Python cell? Can you put them all in the same Python content section? So yeah, do you want to talk me through your strategy for like how you divide things up into cells? I know it's slightly personal, this.
Yeah, that's a great question. There's very different ways to do it. So basically, or at least in Data Lab, right? It depends on the tool you use. What you can use in Data Lab is you open up a Python cell, you write a prompt, it will generate code for you, and then you can remove that prompt and write another one. And then it will take into account the code you already have in the cell, and it will change it, it will augment it, it will enrich it if you want it like that. So that's how you can work iteratively. And you're right. So I could simply keep on reusing the same Python cell to generate all the code that I have here now. The main reason I'm not doing so is because I simply like to logically structure the different code cells into the different tasks we are doing. And that also makes the prompting a bit easier. Otherwise, I would probably write like half a page of text before I would actually see any code.
Yeah, I'm the same way. Whenever I work in notebooks, I prefer to have lots of very short cells rather than a few longer cells. I find it's much easier to just if you want to shuffle the bits of code around, it's just easier to move cells than try and cut and paste lines of code. Much easier to debug what's going on. So I agree with you there that shorter cells are better. All right. Next one from Krishna, saying the distribution of vote count is right skewed. What would the right prompt look like in the zoomed in version? So I guess yeah. I think this was related to the histograms. If you want to
Yes,
zoom in on parts of
exactly.
that.
So basically, this is a great question. When I saw this, I thought, well, this is a great question as a follow-up exercise for anyone who's following this. So what I put in the solution section is try to transform this in a way, like transform the vote count variable in a way that makes the right skew go away and that you can see it in a bit more detail. You can either, if you know how to do it, you can code it up yourself. Otherwise, I would ask the AI to do some kind of log transformation to solve for right skew. And then you'll see that the graph looks a lot different.
Absolutely. And if you're not sure what to do, of course, you can ask the AI, like, how can I how can I improve the graph to make it clearer what's happening in one part of it? So yeah, a few different ways of going about it. Please do have a play around with the AI assistant to see how to get it solved. All right. Next question comes from Alex. So Alex says, do you think the AI assistant should replace manual coding to conserve time, or should manual coding be preserved? So yeah, this is a very hot topic, and it's something actually we this an episode of the Data Frame podcast came out last week with Eran Yahav from Tab9, where we get into this in depth. But yeah, Peter, do you want to talk us through your opinions on like where do you need to write code yourself? Where do you need to use the AI?
So the difficult thing is I'm old enough to remember writing code when we didn't have AI, and I'm not that old yet, so it's a young tool. So my personal opinion on this is that as long as you understand what you're doing, you should leverage it as much as possible as you can. So what I'm doing a lot in my own work is generating a data set and cleaning it and stuff like that is very subjective and business nuanced and those kind of things. And AI is not really good at that. But when your data is finished and you have a clean data set, you'll never be as fast at exploring that data set compared to how AI does it. So any graph I create, any tweak I do to graphs or tables or summary reports, it will almost exclusively be automatically generated code that I either tweak a bit or let AI tweak. And that's been proven very powerful for me.
Absolutely. I think particularly for the exploratory data analysis side of things, where you just want to get lots of answers very quickly, AI, you can do, almost all your code can be AI generated because you can clean it up later. For cases where you've got bigger projects and all the bits of code that are generated have to fit together, you still do need to do a lot more manual work, just with like refactoring code, reorganizing things, making sure that everything makes sense together. So for bigger projects or cases where there are going to be problems if your code isn't like amazing, then that's where you're going to have to do a lot more manual work. And so understanding what the code's doing, being able to just look at code and say, does this look like good code or not? Like understanding code smells, these are very important skills still.
If it's okay for you, we can take 2 minutes to show the final recommender.
I'll jump off and let's see the final answer. And then
Okay,
there's a couple more questions I want to get to, so we'll probably overrun by a couple of minutes.
very good. Okay, so we finished in about 3 minutes of generating embeddings for 9,000 movies. I'll just show you what it looks like. There's nothing to be interpreted here, but just that you get an idea of what's getting spit out. So basically, we've used this field, description of the movie, to generate this set of numbers. That's is some form of representation of the text. And so what we'll do now is, I've already put the prompt in for task 5 is, we'll create a recommending function that takes a description as input. And this description can be anything you write. Just try it out yourself. What will happen is that description will also be encoded, just similarly to what we did here to all the movies. It will be encoded. Then we have an embedding from that description. And from that embedding, we will then apply this cosine similarity function that we used before to all the embeddings of the movies and compare it with the user embedding that we had. This will give us a similarity value, and then we can again sort by similarity, take the top n number, and then return a subset of our movie metadata file. And so the string here that was generated by AI is a thrilling adventure with lots of action and suspense. So now I'm really curious because I haven't seen that description before. What we'll get out of this. Let's just run it and see what happens. So we can see here, suggest King Kong, Fatal Instinct, Quest for Fire. I don't know these movies. It might be correct or incorrect. Let's try to change it up a bit to for example, a superhero movie. Not sure whether this will work. This is a really strong, short description. Sorry. Now just curious what comes out of it. We have Puma Man, waiting for Superman, those kind of things. So it seems that some of the semantic similarity is being caught. Something like that. Now I'm just playing it around live around for you. I don't think that works really well here. So you can see already it won't perform as well as when you're using ChatGPT, but so is live. The last task was actually to put everything together into a single function where you could say, I want to have a recommendation based on popularity or based on a movie I saw already or based on a description. I'll just leave that open for now. You can find it in the solution section, in the solution notebook, and you can play around with it yourself. So I think we can just grab the final questions and then maybe wrap up.
All right, super. So before we go to the final questions, just one thing. We keep these sessions free, but we take payment in like, so please do like the video. Makes it much easier for me to persuade DataCamp management to run more free sessions. So do hit like. The other thing is there is part 3 of this series tomorrow. So please do come back tomorrow. There is a QR code that you can use to register for tomorrow's session. We're going to be talking about business analytics tomorrow. All right. So for those of you who have to jump, please do catch up the rest of the questions on the recording and remember to register in order to get the recording sent to you. All right. So this question comes from Krishna. So Krishna says, can you talk about the pivot table used and the cosine similarity? What is cosine similarity? Why do we care about it?
Let's just see if I can do this succinctly. Here we go. So basically, I just want to show you the concept of this pivot table first. So ratings. Okay, the output's too large. Let's try to see whether this is going to work. Yes. So this is the first 10. So what you can see here is when we have this long data set I talked about is we have a user with a rating and a movie, and the title is repeated a lot because you have many users who watch this movie. But what we ideally would want to do is we would want to have the movie you see here as a column, and then we have the ratings of those users as values in that column. And that's exactly what this pivot table does. So this pivot table will create it, and then I'm curious. I'll be able to print it, I guess. Let's try it out. Okay, so what you can see here is that on the columns, we have all the different movies, and in the rows, we have all the users. And what I meant with the fact that there's lots of missing data is that not all of those users have seen all of those movies and rated it. So if we're lucky, we'll see a rating here, and then maybe a rating here as well. And that's where this fill NA came in, where we put the 0 values in. But if we would like to know whether, let's see here, 300, now I'm just overthinking too much. Here we have some ratings here. So basically, whether A Christmas Story and A Clockwork Orange are similar movies or not, that's where cosine similarity comes in. So we'll do a certain computation that takes all the values we have here and all the values we have in this column and compares them to each other, and then we'll output a 1 if those values are, for instance, all exactly the same, and output a 0 or even a -1, depending on what you use, if all those values are opposite to each other. Like if the same users scored 1 a 5 and the other movie a 1 and vice versa, then those movies are probably very dissimilar. So the notion of cosine similarity is simply a way to capture how related those movies are. You can also think about a correlation or something like that between those two columns.
Yeah, I like that analogy with correlation, because they're both scores between -1 if they're opposites and 1 if they're kind of the same thing. So in this case, yeah, it's just like thinking about the angle of the embeddings. Are they the same? How closely related are they? All
Yeah,
right,
I didn't
nice.
want to say that. Sorry.
So that was just the very technical explanation. I think yours was nicer. It's a bit like correlation is a much easier thing to remember. All right, so let's do one more question. So this comes from Hoja. I will pronounce that some close to correct. So once you got this similarity matrix, even with like just a few thousand movies, that's still a big matrix. So I guess at some point, what happens when just data set gets bigger? Because it's the number of items you have squared. So I don't know. Suppose
Yes,
you're Amazon, you've got like what, millions, hundreds of millions of products. That's going to be a big matrix.
that's why tutorials are always nicer than the real world. Yeah. So basically, you're absolutely right. When you want to do this on a real life situation, you'll always face these kind of memory issues. If you're asking that if the AI would be then intelligent enough to detect this, no, absolutely not. It will just generate code for you that will crash, and you'll be stuck if you don't know how to end it. But just on the part of the size of the data, most of data science problems are difficult, not because of the modeling aspect per se, I would say, because that's largely solved, but it's all about the features that go into it and how many there are. And if the data set is really big, you have to get very smart in how you do that on the cloud and stuff like that. It's not for a tutorial here, but it's a very legitimate question because, yeah, any real life situation you wouldn't be able to handle with this.
Yeah, so I suppose the big thing in this case with the matrix is most of the values were missing, so you could use a
Yes.
sparse matrix, and that's going to dramatically decrease the size of or the amount of memory that it takes up. So but you'd probably have to explicitly tell the AI, I've got a big data set, use a sparse matrix. The other thing is if you've got this stored in a database um, rather than a Python pandas data frame, then it's going to be you're going to have like a lot more space for bigger data sets. So yeah, plenty of big data tools out there. You just got to make sure to explicitly use those. All right. With that, we are well past time, so let's wrap up. Thank you once again, Peter. Very, very cool stuff. And yeah, I'm still slightly amazed that American Beauty was one of the movies that was close to The Godfather. That's going to be bugging me for the rest of the day now. But otherwise, very, very, very cool stuff. All right. Thank you to everyone in the audience who asked a question. Make use of that QR code. I want to see you back again tomorrow. Please do register. Yeah, thank you for showing up today. See you again.